Hello friends, welcome to UGPG Mathematics. In this video, I am going to solve problems from IIT-JAM 2020. So let us see the first problem. We have to find the double integral of e raised to x square dx dy, where the limits of x are from 2y to 2 and y limits of y are 0 to 1. So let us find it. Now we know that this e raised to x square we cannot integrate it directly, so we will change the order of this integration. So first write down the region. So x is equal to 2y and x is equal to 2. So let us say this is the line x equal to 2, and so x equal to 2y will be this, and here we have y is varying from 0 to 1. So y equal to 0 means x-axis, and y is equal to 1 means this line. So our region of integration is this. So we will just transform it. So now x is equal to 2 is again this line only, and this x is equal to 2y. Now change the limits of integration. Here x is varying from 2y to, that means x is from left to right, 2y to 2. So take the limits of y here. So y is varying from, now this is the equation of y. So y is varying from 0 to, this line is y is equal to x by 2, because x equal to 2y means y is equal to x by 2. So we are considering vertical strip here. Along this, y is varying from 0 to x by 2, and on the same line the limits of x are, x is varying from this 0 to 2. So this integration becomes x is varying from 0 to 2 and y is from 0 to x by 2, e raised to x square as it is. Now the limit, we have to change the order of this, so it is dy dx. Now let us solve it. So this is independent of y, so this is just x is from 0 to 2. So e raised to x square as it is, and you integrate this y from 0 to x by 2. Dy means it is just 1 dy and dx. So when you integrate this, we will get x equal to 0 to 2 e raised to x square. Now this integration is just y. Integral of 1 is with respect to dy is y, 0 to x by 2 dx. Now this is equal to, x is from 0 to 2 e raised to x square. This is x by 2 minus 0 dx. So this is just equal to, x is from 0 to 2, x 1 by 2 into e raised to x square dx. Now this is easy because we can substitute. Let us say x square is equal to, say, t. So this will imply 2x dx is equal to dt, and hence this x dx is equal to dt by 2. Now change the limits. So it is, when x is equal to 0, t is equal to 0 square, which is same as 0, and when x is equal to 2, it is t is equal to 2 square, which is 4. So our integration becomes 1 by 2 outside. Now this x into dx is just equal to dt by 2, and e raised to x square is, when you put x square equal to t, it is just e raised to t. Write down the limits. T is from 0 to 4. So solve it. It is 1 by 4 into integration of e raised to t is as it is, e raised to t, and write down the limits. So t is from 0 to 4. So solve it. 1 by 4 into e raised to 4 minus e raised to 0 which is equal to 1 by 4 into e raised to 4 minus 1. E raised to 0 is 1. Now let us solve another question. The question is, we have given two series, minus 1 raised to n upon 2 raised to n plus 3. Let us say that this has a summation an, and let us say another series as summation bn, which is minus 1 raised to n upon 2n minus 3. And we have asked about the conditional convergence or absolutely convergence of this series. So let us solve. So we have this mod of an. To find out the absolute convergence, we have to take first the modulus of this series. So modulus of minus 1 raised to n upon 2 raised to n plus 3. Now this minus 1 raised to n is just 1. 2 raised to n is positive. 2 raised to n plus 3, it is just 1 upon 2 raised to n plus 3. Now we know that this 2 raised to n plus 3 is greater than 2 raised to n. Hence, this 1 by 2 raised to n plus 3 is less than 1 by 2 raised to n. So, this series, so modulus of an is equal to 1 by 2 raised to n plus 3 is less than 1 by 2 raised to n. So, when you apply summation on both the sides, we will get this summation of mod an is less than summation of 1 by 2 raised to n, and this n is varying from 1 to infinity. So now this series is dominated by 1 by 2 raised to n, and this series is convergent. So because it is geometric series with the common ratio is 1 by 2, and which is less than 1. Summation r raised to n and runs from 1 to infinity is convergent. It is geometric series, is convergent if this modulus of r is less than 1, and here this r is equal to 1 by 2. So it is clearly less than 1. So this series is convergent, so this dominated series must be convergent by comparison test, and therefore this summation mod an is convergent. That is, the series minus 1 raised to n by 2 raised to n plus 3 is absolutely convergent, because its modulus of this series is convergent, correct? So we will say that it is absolutely convergent, and we know that if a series is absolutely convergent, then it is convergent also. So the series is also convergent. Now let us go for summation bn. So this series is we first take the modulus. If it is absolutely convergent, then the series itself is a convergent series. If it is not, then we will go by Leibniz test to see whether this Bn converges or not. So let us find first its modulus. So modulus Bn is equal to modulus of minus 1 raised to n divided by 2n minus 3, which is same as 1 upon 2n minus 3. Now just observe this, that this 2n minus 3 is always less than 2n. So this will imply 1 by 2n minus 3 is greater than 1 by 2n, correct? So this thing is greater than 1 by 2n. And now we know that, that means therefore this mod Bn is greater than 1 by 2n. And when you apply sum on both the sides, then we will get, so summation of mod Bn is greater than summation, you take 1 by 2 outside, so summation 1 by n. And now we know that this series 1 by n is divergent. So this by comparison test, this summation modulus of Bn must be divergent, and therefore summation mod Bn is divergent. That is, this summation Bn is not absolutely convergent because its modulus is not convergent, correct? Now let us see whether this Bn converges or not. So here Bn is equal to minus 1 raised to n divided by 2n minus 3. So obviously it is alternating series, so we will use Leibniz test. So apart from the sign, we have this Bn. Let us say that summation is equal to this. It is same as summation of called it as Cn minus 1 raised to n Cn n runs from 1 to infinity. That means in our case Cn is equal to 1 by 2n minus 3. So by Leibniz test, we must have this Cn n runs from 1 to infinity is a decreasing or non-increasing sequence, and the limit of Cn must be 0. Then by Leibniz test, we say that this series Bn is convergent. So let us see whether this limit Cn is equal to 0 or not. So clearly, if we have this limit as n tends to infinity of Cn is equal to limit as n tends to infinity of 1 by 2n minus 3. Now as n tends to infinity, 2n minus 3 tends to infinity. So 1 upon infinity tends to 0. So this clearly, this is equal to 0. So this condition is satisfied by Cn. Now let us see whether this is satisfied or not. So let Cn is just 1 by 2n minus 1. This is the sequence. Now as we done before, this 2n minus 3 is just less than 2n. So or you can use this n plus 1 criteria. So this is our Cn. So Cn plus 1 is just equal to 1 by 2n plus 2 minus 3, which is same as 1 by 2n minus 1. And now we know that this 2n minus 1 is greater than 2n minus 3. So this gives us 1 by 2n minus 1 is less than 1 by 2n minus 3, which gives us this 1 by 2n minus 1 is just nothing but Cn plus 1, which is less than 1 by 2n minus 3 is Cn. So by this, and this holds for all n. So for all n, we have Cn plus 1 is less than Cn. So this implies this sequence Cn n runs from 1 to infinity is a decreasing sequence or non-increasing sequence, and hence this first condition is also satisfied by Cn, and therefore by Leibniz test, we have this summation Bn is convergent. Now this series is convergent, but it is not absolutely convergent, and therefore this summation Bn is conditionally convergent. Now let us solve another question. So here we have given a function f of xy is equal to e raised to x into sine y, and x is equal to t square plus 1, y is equal to t square plus t. So, and we have to find out df by dt at t equal to 0. So use chain rule, because f is a function of x and y. Let us write down this diagram. F is a function of x and y, and x and y are functions of t, the variable t, and we have to find out df by dt. So there are two ways to reach t. So first is this. So you calculate df by dx or del f by del x, because here it is a function of two variables, so it involves partial derivative and the derivative of this with respect to t. Then the second way is you first find out derivative of df by f with respect to y, and then find out the derivative of y with respect to t. So by chain rule, therefore by chain rule, this df by dt is equal to df by dx into dx by dt. I am writing this as dx by dt because x is just a function of t. So I replace this del x by del t by dx by dt. Similarly df by dy, because there are two ways, so you add first this thing plus the second way. So df by dy into dy by dt. And now just find out the derivatives. So when you differentiate this with respect to x, we will get this e raised to x as it is. Now sin y is just, now this e raised to x, for simplicity, e raised to x into sin y is equal to e raised to x into, yes, you write this, when you write the partial derivative of this with respect to x, now you use the partial derivatives rule to integrate this. Now see, this sin y is independent of x, so you treat it as just constant, so it will be just e raised to x into sin y, and the derivative of x into sin y with respect to x is just sin y. You just use this, so del by del x of e raised to u, where this u is a function of x and y, it is just equal to e raised to u into del u by del x. So you treat u is equal to x into sin y, so when you differentiate u with respect to x, you will just get sin y, correct? So, and similarly you take the partial derivative of e raised to x into sin y with respect to y, so it is just equal to e raised to u is as it is x into sin y, and take the derivative, just replace this u x by y, so this will be just du by dy. So take the partial derivative of x into sin y with respect to y, so x will be as it is, and this derivative of sin y with respect to y is cos y. So write it down, and df by dy is e raised to x into sin y into x cos y, and df by, this is dy by dt as it is, and this is sin y. So I am writing this below, so df by dt will be del f by df by dt is equal to df by dx, put the value, so it is just sin y e raised to x sin y, then dx by dt is, find out the derivative of x with respect to t, that is 2t, plus df by del f by del y is x into cos y into e raised to x sin y, and the dy by dt is just put the value of dy by dt, which is 2t plus 1, correct? Now just put x is equal to t square plus 1 and y is equal to t square plus t, so this is just equal to sine of t square plus t into e raised to t square plus 1 into t square sine of t square plus t into 2t plus x is t square plus 1 into cos of y is t square plus t into e raised to t square plus 1 into sine of t square plus t, then 2t plus 1. Now we have to find out the derivative at t equal to 0, so put t is equal to 0, we'll get this as, now when you put this is equal to t equal to 0, this is 0 plus 0 is sine 0, now sine 0 is 0 and 0 into anything will be just 0, plus this is 0 plus 1 which is just 1, now cos of 0, this is e raised to 0, sine of 0 is 0, so 0 into anything will be just 0, and into 2 into 0 plus 1 which is just 1. Now e raised to 0 is 1, cos 0 is 1, 1 into everything is just 1, 1, 1, so it is just equal to 1. This is the answer. Now let us find out the radius of convergence of this power series. So let us call this as summation n runs from 1 to infinity a n x raised to n. So here an is equal to n plus 2 divided by n whole thing raised to n square. So to find out this, we use the ratio test, the root test, because here the power is n square, So by root test, we take an raised to 1 by n first, which is equal to n plus 2 divided by n raised to n square. Take the modulus raised to 1 by n. Now this is just equal to n plus 2 by n raised to n square divided by n, because this is a positive quantity, so its modulus is equal to itself, and this is divided by n. So this is equal to n plus 2 by n raised to n. And now we have to take the limit. So limit as n tends to infinity of mod an raised to 1 by n is equal to limit as n tends to infinity of this thing, which is just equal to 1 plus 2 by n raised to n, which is just equal to 1 by e square. 1 e raised to 1 by 2, not e square. So because since limit as n tends to infinity of 1 plus k by n raised to n is equal to e raised to 1 by k. So this is e raised to k. So change this, which is just, now here k is 2, so it is e square, and therefore the radius of convergence r is equal to e square.